Hello students, in this video we are going to learn about Venn Euler diagram or simply Venn diagram. The Venn diagram is a way of representing relationship between the sets. These diagrams consist of rectangles and circles. Usually universal set is represented by a rectangle. So now we will see the representation of elements of a set. For example, if I consider set A of elements 1, 2, 3, this will be represented in Venn diagram as the universal set, which is rectangle. In the right side corner we will write mu, which represents universal set. Now we consider circle, which says that these elements are, this is called as set. This is how we are going to represent sets in a Venn diagram. In a Venn diagram, overlapping of sets represents at least one common element in both the sets. For example, take set A and another set B. We can clearly see there is overlapping here. So in this overlapping, there will be at least one element or more than one element in common from both the sets. And in this case, two sets don't overlap, then we say that there are no common elements in these two sets. That means the sets P and Q are clearly disjoint. Now we will see one example of a superset and subset. First we will draw a Venn diagram, then we will see with the help of some elements. So first of all, I am considering that set B is subset of A. That means inside this universal set we have set A, and since B is a subset of A, B lies inside of A, set B. And this is the Venn diagrammatic representation of B is a subset of A. Now we will take some examples. Let set A is equal to 1, 2, 3, 4 and 5. Set B represents 2 and 3. So we have to represent it in the form of a Venn diagram. First we will draw a universal set, and we will take set A, and inside it we will take, since B is a subset of A. Now you see what are the elements of B. 2 and 3 are the elements of set B. And now you will see what are the elements of A. 1, 2 is already here, 3 is already inside, We'll take 4 and the remaining last element is. So like this we can represent B intersection, sorry, B is a subset of A. So we'll see what is superset of, what is the superset in these two sets. So from this example we came to know that B is a subset of, since B is subset of A, B is subset of A. So A is called superset of A. A is called superset of B, because here B is situated inside this one, this E set A. A is called superset of B, and since B is inside, B is called subset of A. This is all about subset and superset. Next we will see about union of sets. What is union of sets? Union of sets is nothing but writing all the elements in both the sets without repetitions. First we will try to draw the Venn diagram for this one. So I draw an universal set represented by mu. I take set A and set B. I think you remember that while writing A union B, definitely the elements are, some elements are common. So as we join all the elements together and write as a single set, we will represent A union B like this. So here we write A union B is nothing but shaded part. The shaded part is A union B. Now let us take one example. Set A is equal to 1, 2, 3, 4, 5. Set B is equal to 3, 4, 5, 6. Usually while writing this one, we will write A union B is equal to 1, 2, 3. So you can observe here 3 is in both the sets, 4 is in both the sets, 5 is also in both the sets. So we will write it only once. 3, 4, 5. And last one is, so this is A union. This will show it as form of Venn diagram. This is universal set, set A, and this is set B. What are the common elements that we are going to write here? What are the common elements there? 3, 4, 5. So while writing set A, we have 1, 2, 3, 4, 5. And while writing B, set B, we have 3, 4, 5 and So this is A union B. Now we'll see about intersection of sets. First we'll try to draw the Venn diagram without elements, and then we'll consider one example for it. So first we'll draw the universal set. Universal set A, set B. While representing this intersection, according to the definition, we'll consider only the common elements. Only the common elements. So A intersection B, nothing but only this shape. Let us consider one example. Set A is equal to 1, 2, 3. Set B is equal to 2, 4. And we have to see what are the common elements in both the sets. 2 is here, also 2. 4 is in A and also B. Similarly, 6 is in A, also in B. So while we calculate this A intersection B, we are going to write like this: 2 comma, that is the answer. So while representing Venn diagram using elements, we'll draw universal set A, now we'll take what are the elements in set A. 1, since 2 is common, right here. 3, 4 is also common, right here. 5, 6 is also common. This is an example for intersection of. We'll try to consider one more example. Set A is equal to 1, 3, 5. Set B is equal to 2. As you can see here, very clearly we can say that there are no common elements in both sets. Then the intersection of this set is nothing but an empty set. So to represent this one, we will do draw sets A and B. A so what are the elements of A? 1, and elements of B 4. Since these two are apart from each other and there is no overlapping, as I told you earlier, these two sets are called difference of sets. So difference of sets, it may be, for example, it may be A minus B, or it may be B minus. The standard notation we use for this one is set of all x such that x belongs to A and x does not belongs to. Similarly, here also set of all x such that x belongs to B and x does not belongs to. So if you can see here, the first set is A. That's why in the difference of sets, we will consider only the elements in the first set here, that is A. And in the second case, the first set is B, and here also we are considering only the leftover elements from set B. We don't want to take elements, or we doesn't bother about the second set. First we will see the Venn diagram of A minus B. Take one universal set. Present mu here. We'll take A. This one is set B. A set. So while drawing this one, we'll shade according to this formula or standard notation. We have to consider only the elements which are left over in first set, that is set is A. Similarly, we'll draw a set representing Venn diagram representing B minus A. Our set doesn't matter, you can take B here or A. Taking A only here. Here it is B. Now, since this is B minus A, we have to consider only the leftover elements in this part. So this is B minus A. So let us take some examples. Set A is equal to 1, 2, 3, 5, 6. Set B is equal to 2, 4. Sorry, 2 and so as usual we will calculate A difference B is equal. First we will see what are the common elements in both the sets. Here 2 is common, here 4 is common, here we have 2. So now while doing this difference, we will strike off those elements from first set. And what are the elements remaining here? Is remaining, 3 is remaining, 5 is remaining, and this is A minus. For the same we can represent Venn diagram. First we'll write the common elements in part, only elements in B. And what are the remaining elements here? 1, these elements are the leftover elements in set A. That's why A minus B is equal to 1, 3, 5 and 6. Similarly, we consider one more rest. example, difference has b minus a, that b is equal to 1 2 5. Yes, a consists of elements 1. Now the difference between these two, we have to identify the common elements. Here 2 3 4 5, 2 3 5 are common in both the sets. So you have to remember this is set B and this is, you have to remember that while doing this difference we'll strike off only in the first set, like this 2 3 4 5, and what are the elements remaining is our final answer is set 1. For this also we can represent a diagram. This U universal set, set A, set B, set A. So I have to write what are the common elements here. Yes. Set this, and we'll write common elements here. What are the common elements? 2 3 4 and 5. So apart from these elements in set A we have an additional element, that is 6. Then what is the leftover element in the answer? We have here as 1. So that is the leftover element in set B, that is 1. So in this way we can represent union, intersection, as well as difference of sets by using Venn diagrams. And finally I want to show you the number systems, the sets we have as a universal set. For example, consider this very big universal set represented by mu, and there is a initial set is natural number. Next to that we have whole numbers. After that we have integers. After these integers we have rational number. Rational numbers and irrational numbers together is real numbers. Now all these sets are sets of complex number. So this is, I think, a very good example for an universal set. I hope you understand about how to draw Venn diagrams for union, intersection, and difference of sets, as well as subset and supersets. Thank you.